All right, I'm actually going to skip the other problem that I had planned just because of its complexity, and I want to just look at a little bit more simple, straightforward one for today. We'll look at that other one tomorrow. So this is a past AP exam problem, or at least part of it, and we're going to go through and basically solve it. So we have our experiment and reaction. I forgot to copy the reaction over, but that's okay. We can see it's chlorine, manganese, or manganate, sorry, and hydrogen. So if we were to write the rate law, which we'll do a little bit later in the experiment or in the problem, it would be rate equals K, concentration of Cl minus to the X, concentration of MnO4 minus to the Y, and the concentration of H plus to the Z. And it's going to be our job to go through and calculate what those are using our wonderful, pretty, amazing data up here. So again, what we're going to try to do is find experiments where 2 of the 3 are being isolated, meaning they're not changing, and 1 is being changed, so we can figure out what that change is. So mathematically, if we're looking at this equation down here, what we're essentially doing is comparing 2 of these equations, 2 of the exact same equations, and trying to isolate the variables. So if we were looking at, let's say, experiment 1 and 2, chlorine, or the chloride ion is changing, but permanganate is not, and hydrogen is not, and our rate law is. So what we're essentially isolating is just this aspect, oops, not trying to move all that, sorry, this aspect right here. So the rate equals K times Cl minus to the X, and actually we're isolating K too because K is a constant. So it's really just rate equals Cl minus to the X. So we end up with being able to isolate our numbers and figure out what X is and solving it out from there. So if we go back up here, we're going from 0.014 to 0.032. And if we were to look at what that ratio actually is, whoops, hold on. Sorry guys, this thing's being a little bit spazzy this morning. It's not calibrated. Apparently it's not feeling good either, like my daughter. There we go. So that's down there. Come up a little bit higher. There we go. If I was to look at these, I'm so sorry guys. Look at these values. I'm tripling my concentration. So then I jump over here to my rate, and I kind of want to see what's going on between these 2 rates. And I can do that by just doing some basic math and determining what that ratio is between those 2 values. So I typically would divide the bigger one, the 2.03 times 10 to the negative 7th, by the smaller one, 2.25 times 10 to the negative 8. And what I'm actually getting is this ratio to be 9. So if I jump down here to where we got our rate law, essentially what I'm doing is I'm taking a rate that's being multiplied by 9, and that's going to equal a value of 3, because I'm tripling my concentration, to the X. And now if I want to solve for X, what I'm essentially getting is X is 2. It's in the second order because 3 raised to the second power, or 3 times 3, gives me 9. So that means chlorine has an order of 2 throughout this process. And it asks for a justification of the answer. The justification essentially is the math, and just working through the math and being able to say, because I tripled my rate, I tripled my concentration, I multiplied my rate by 9, which gives me a second order. And you can do it the math way too down here, kind of it through that explanation. Okay, now we're going to go do the same thing with the permanganate ion. And we're going to look at experiments 2 and 3 here, because if we look, chloride and hydrogen are being held constant, but we are changing the permanganate. And you can look at this 2 different ways. I have a tendency to like looking at it from whole numbers, so I'm actually going to compare 3 to 2 versus 2 to 3. 2 to 3, I'd be halving my concentration, and then I'd have to figure out what was going on over here, which visibly we can see it's halving as well. Or I can look at it from a perspective of 3 to 2, where I'm doubling. Golly, sorry guys, this thing is so off kilter. Nope, I can't even write on here, but it's 2. This is 2. It's doubling, so when I come over here, I also have a double for my rate, which means if I come down here to this guy and do that same process again, I would have my rate equals 2, doubling it. 2 to the y gives me what? Well, y must be 1 in this case. So we would say permanganate is in the first order because doubling concentration doubles rate. Whatever I do to rate, or whatever I do to concentration, doubles my rate. So there's my 2 orders. So if we keep coming down, it then says a reaction known to be in third order with respect to H, so they already gave us a Z. Okay, using the information, write your rate law for the reaction. So this is what we did just a minute ago, but now we actually have values to plug in. So our rate is going to equal K times the concentration of chlorine, which we said is in the second order, times the concentration of permanganate, which we said is in the first, times the concentration of hydrogen, which they told us is in the third order. Now from there, some things that you could do. We could calculate our K value, which is actually what it's actually asking us to do. We could calculate rate, we can calculate individual concentrations depending on what data we were given. So if I jump back up here, let's say there was an experiment 4, and they gave us concentration for chlorine, permanganate, and hydrogen, but they didn't give us a rate. Well, all we'd have to do is plug in our values. We would have to know K there, but it would just be plugging it in and solving out. Same thing if they gave us rate, and we already calculated K, and they want us to calculate one of these concentrations. So essentially, we can use this as a equation to solve everything out. Now, the first thing that's very common is to calculate the K value for these reactions, and units are a big deal here. They want to know the units, so we'll fight with units in a minute. But how do we calculate K? We pick one of these experiments and we plug it in. In all reality, that's all it is. So if we were going to do that, we would have, let's say we grab the first experiment. It doesn't matter which one you grab. Our rate for the first one is 2.25 times 10 to the negative 8th. And I'm going to have to scroll back up and down here. Sorry, guys. 2.25 times 10 to the negative 8 equals K, which is what we're trying to solve for. We need the concentration of chlorine for that first experiment, which is 0.0104. Please excuse Riley. I don't know if you can hear her actually in the background or not. 0.0104. Sorry about that. And that's to the second power. Then we're going to go back up here and grab permanganate. Permanganate is 0.00400. There we go. I think that should be 0.0040, and I apologize to the 1. Yeah, it's 0.00. And then the last one is 3. So let me rewrite this real quick. 0.00400 to the 1, and then this guy's to the 3, which is 3.00 to the 3. So if we go through and calculate the value of K, which is pretty straightforward, we take 0.0104, multiply by 2, square it, 0.00400 to the 1, and then 3 to the third, and we calculate that value, divide it over on this side, and we get a K value. So take a second, calculate that out real quick. All right, what I'm getting for my K value, if I put this in correctly, which I am using my cell phone, so there's a distinct possibility that something went wrong, so just kind of double check. What I'm getting is 1.93 times 10 to the negative third for my value here. So see if you got the same thing. Now, let's talk about units. Units are kind of a pain here, but they're not too bad. They take a little bit of work. So if we were to go through and look at this, our unit for rate, if we go back up here all the way to the top, is molarity per second. So I know that because I have capital M, which is moles per liter, and second to the negative 1, which means per. So I'm going to write that a little bit differently. I'm going to keep that guy up there. And I'm going to write that as moles over liters times second. That equals K. I then have moles per liter squared, because remember these guys are concentrations. These guys are concentrations, so concentration is moles per liter. I'm then going to have moles per liter to the 1, and then moles per liter to the cubed. So if I go through and look at this, this is basic math. We're going to use it as we would X. Moles per liter moles per liter squared would be moles squared over liters squared. And then I have that multiplied by moles to the 1 over liters to the 1, multiplied by moles to the cubed over liters cubed. Well, what does that leave me with? Well, exponents, when we multiply, add together. So I end up with moles squared plus moles to the 1 plus moles to the third. And I'm adding the exponents, not the actual values. Those are being multiplied. What that's going to eventually give me is moles to the 6 over liters to the 6. So kind of a pain, but it is what it is. Now, that's multiplied by K, and then we have moles over liters seconds. Well, how do we get K by itself? We divide. Well, when we divide by a fraction, we're multiplying by the reciprocal. So that gets rid of this guy. Now we jump over here, And we're going to multiply by that liters, 6 over moles to the 6. Well, one of the moles is going to cancel out, and we're going to be left with moles to the 5th over here. And one of the liters is going to be canceled out, and we're going to be left with liters to the 5th. So what's our actual final unit? Jump back up here. Where is it? There it is. Liters to the 5th over moles to the 5th times seconds. Seconds did not cancel out. So while it's a little tedious, that's essentially where we end up with. All right, guys, what I want you to do, you have 2 problems I want you just to try working through. I expect questions. I expect you not to be perfect at this, but I want you to try them, see where you end up. If you have questions, make sure you jot them down, and we will go over this tomorrow, and we will go through integrated rate law tomorrow as well. Thanks, guys. Hope you guys are doing well.